Hello friends, I welcome you all in the introductory lecture of nanotechnology. Myself Dr. PM Wankade. So we will start with the history of nanotechnology. The word nano is derived from the Greek word nanos. The word atom was coined by Democritus as early as 400 BC. The picture of Democritus is as shown on the slides. It denotes the smallest particle as an indivisible any further, and then since the entire world of science devoted itself to study physical, chemical and natural phenomena. Nanomaterials were used by people since ancient times. Pottery using nano-sized particle has been in use for many years. The glass cups appears green in reflected light, but when light rays enter in a cup from inside, it appears red from outside. This type of optical effect is caused by adding silver and gold nano-sized particle while preparing the glass. During 1450 to 1600 AD, while coloring to achieve the red and gold luster effects, very small size particle of copper and silver were used. The addition of these nanoparticles cause light to bounce off their surface at different wavelengths, giving metallic effect. In 1865, Michael Faraday prepared the first colloids. Colloids are nothing but the fine particles which are suspended in a solution and had special electronic and optical properties. Nanotechnology has its root in the landmark lecture delivered by the famous Nobel laureate physicist, that is nothing but Richard Feynman, on 29 December 1959, entitled "There is a plenty of room at the bottom." He said that development of technologies to construct small systems of work be interdisciplinary and would offer a new world of possibilities that could radically change the technology around us. In 1957, Eric Dexter published the book entitled Engines of Creation, and he is described as the founding father of nanotechnology. He established the main fundamentals of molecular engineering and described the implementation and application of advanced nanotechnologies. Drexler was also one of the co-founders of the Foresight Institute, that is the primary force pushing for the kind of nanotechnology that will truly transform our future from medicine to environment to space. In 1974, the term nanotechnology was first used by Norio Taniguchi. He used this word nano for the production technology to get the extra high accuracy and ultra fine dimension in a scientific conference. These are the pictures of founder of nanotechnology. Is a Feynman, who gives the basic of nanotechnology in his lecture in 1959. The nanotechnology first term is used by Taniguchi in 1974. Before that one, Drexler as the founder of nanotechnology. We have discussed the main history of nanotechnology. Apart from this one, in 1960, NASA researchers discovered nano-sized particles of iron. Charles Planck and Edward Rosinski developed a process to speed up chemical reaction using zeolites. Sir C.V. Raman won the Nobel Prize for his discovery of scattering of light, as we all aware about this one. This scattering of light provides the size of the particle from which it is scattered. But Raman's spectroscopy was not able of detecting particles at nano size. Richard P. and Van Duyn discovered surface enhanced Raman spectroscopy. I again repeat that, SERS. S stands for surface, E stands for enhance, R stands for Raman, and spectroscopy, S stands for spectroscopy, from which it is possible to study the nano size particle. That is the SERS, which is proposed by Richard and Van, remove some of the limitations of Raman spectroscopy. They showed that the size of the molecule reduces to 100 to 50 nanometer. Then the Raman intensity increased to 10 raised to power 6 times due to the discovery of surface enhanced Raman spectroscopy. The most sensitive technique in molecular spectroscopy is available. On further, in 1981, the scanning tunneling microscope was invented by Binning and Heinrich. Due to the invention of scanning tunneling microscopy, it is possible to observe nano-sized particles and to study the form of molecules and control them. In the next 7 years, that is in 1988, Dr. Lewis discovered nano-sized crystal semiconductor material prepared from the same substance have different colors. These nanocrystal semiconductors were termed as quantum dots. We will discuss quantum effect or quantum dot in our next title. So today, silicon chip making technology easier one. Nanowires be the building blocks for almost any kind of application in electronics. Biochemical detection and is helpful for making thin film. So all of these are the history of nanotechnology, and these are the main founders of nanotechnology. In the next topic, we will discuss about the synthesis of nanoparticles. Nanotechnology is a highly multidisciplinary field. It includes fields such as applied physics, material science, interference, and colloidal science, supermolecular chemistry, and all the engineering fields. Nanotechnology is the science of designing, producing, and using structures and devices having one or more dimensions of about 100 millionth of a millimeter, that is 100 nanometer or less. Such atomic scale fabrication is known as bottom up approach as opposed to the top down approach that we are accused to. The current top down method for manufacturing involves the construction of parts through methods such as chemical etching, sputtering, laser ablation, and mechanical milling. While the bottom-up approach includes soil gel, aerosol process, laser pyrolysis, vapor deposition. In the bottom-up approach, it includes biological methods, that is bacteria, yeast, fungi and plants. So all these are the synthesis of these are the different methods used to synthesize the nanoparticles. So up till now we have transformed from nanotechnology to nanoparticles. So definitely a question may be raised in your minds. So what is nanoparticles? So in nanotechnology, a particle is defined as a small object that behave as a whole unit in terms of its transport properties. It is further classified according to size in terms of diameter. Fine particle cover a range between 100 to 2500 nanometer, while ultrafine particles on the other hand are sized between 1 to 100 nanometers. Similarly to ultrafine particles, nanoparticles are sized between 1 to 100 nanometers. Through the size limitation can be restricted to 2 dimensions. Nanoparticles may or may not exhibit size-related intensive properties that differ significantly from those observed in fine particles or bulk materials. So overall, if the particle size ranges from 1 to 100 nanometers, that particles are called as or termed as nanoparticles. Nanomaterials are available in different forms like colloids, powders, tubes, rods, wires and thin film and much more. Out of this synthesis process, we will briefly discuss laser pyrolysis. In this method, synthesis of nanomaterials are performed by using high power laser beam. The laser pyrolysis method was employed in the gas phase for the synthesis of different nanocomposites or nanoparticles. Many materials like Al2O3, Si3N4 are synthesized in nanocrystalline form by this technique. The particle size and their distribution mainly depends on the gas pressure and substrate temperature. So in the next lecture, we will discuss about the quantum size effect. Okay. Next we will discuss the quantum size effect. Science based on the laws of Newton and Maxwell are termed as classical mechanics. After the discovery of atom, it was observed that these atoms do not obey laws given by Newton and Maxwell. So a new branch of physics known as quantum mechanics was introduced by the scientists. Due to this quantum mechanics, it can be clear that which law can be obeyed by electrons, protons, neutrons, photons or other elementary particles. When the size of material particle becomes so small that when it takes atomic size, then it does not obey the laws of classical mechanics, but it obeys the laws of quantum mechanics. However, the nanoparticles have the dimensions ranges up to 100 nanometer. So therefore, classical mechanics will not be applied here. So from that point of view, quantum mechanics is the better option to study the nanoparticles. The basic property of a metal is its color and luster. By reducing the size of the particle, they can be made to emit or absorb specific wavelength, that is color of light. Quantum confinement effect explains the relationship between the size and color for nanocrystal. These nanocrystal semiconductors were termed as quantum dots, which is proposed in